Hi, it's time for another math easy solution. Now, to discuss further into hyperbolic trigonometric identities, and now look at the half angle identity, sinh x over 2, or hyperbolic sine x over 2. Let's just jump right in. So this is known as a half angle or half argument identity, and recall from my earlier video cosh on cosh 2x corollary number 2 of that double angle identity video, which was actually my last video, so check that out. So we could use that corollary number 2 formula, which was cosh 2 theta equals to 1 plus 2 sinh squared theta. So because it's a double angle, we have 2 theta and then there's a theta like that. We could basically divide these out so we can get an x over 2 and an x, and then we could basically write it as a half angle identity. So in our case, what we could do is we want an x over 2, so we could let theta here equals to x over 2, so that when you multiply these out by 2, we get 2 theta equals to, well, x. So then this can replace by x, this can replace by x over 2, and then we just need to rearrange to get an identity for sinh. Yeah, so then what we end up getting is I'll write this over here, cosh 2 theta is x equals to 1 plus 2 sinh squared, and then this is going to be an x over 2. So all we did right now was transform the the double angle to a half angle identity like this, and then we're going to simplify this out. What we'll do here is I'll move this 1 over to this side, so subtract it, and then divide the 2 out, so we get a sinh squared x over 2 equals to a cosh x minus 1 over 2, like this. But now what we could do is to get rid of this square, but also you could just use this as an identity on by itself. But if we want to get just a sinh, we could square both or square root both sides like this, and then the square cancels. We get a sinh x over 2 equals to, so let's put this sinh like that, equals to now a plus or minus, because this sinh could be a plus or minus, and we don't know which, because when you square it, it could be either or. So now what we'll have on this side is going to be just square root this whole thing like that, cosh x minus 1 over 2. Yeah, so we have this, but we have a plus or minus. Now to try to get rid of that plus or minus, first what we'll do is try to analyze the behavior of sinh and cosh as x changes, and here's a graph of it. I might go over a later video going over this manually to prove this, but here's how sinh is in red. It's negative here, then becomes 0, and then goes to positive like that. So positive, negative, and there is 0 at the 0. And then here cosh is 1 here, and then it just goes positive. It's always positive, and it's always greater than 1. So I'll write note like this. Yeah, I'll write here. So I'll write note that sinh x here is just a x like that. That's the x-axis. This is the y-axis like that. Yeah, so from that graph, sinh is, well, this is going to be less than 0 for x is less than 0, and then this equals 0 for x equals 0, and then it's just going to be, well, greater than 0 for x is less than, x is greater than 0 like that. Also what we have is the cosh one like that. Cosh is just, I'll write cosh of x is greater than or equal to 0, equal to 1 actually, for x is element of all real numbers like this. Yeah, like that. So x could be any real number, and usually write it like this, element of all real numbers, and it equals to 1 for x equals to 0. And yeah, basically this checks out when you have a cosh x minus 1 like this over 2. This is going to be, well, square root like that. So then this is going to be greater than or equal to 0, because the lowest one here could be is 1. 1 minus 1 is 0, and then this is 2. So it's greater than or equal to 0 for x element of all real numbers like that. Yeah, so we don't have to restrict the domain when we take a square root like that. Yeah, so thus when we put this all together, what we end up having is, so I'll write thus for the half angle identity, sinh x over 2 equals to, so this equals to, yeah, when we look at this, so when it's x is less than 0, it's going to be negative, because we have never plus or minus like that, so we want to break that down. This is going to equal to negative square root cosh x minus 1 over 2. This is for x is less than 0, and then it equals to, well, 0, because when x is 0, you can even look at it both sides. Sinh x, sinh 0 is going to be 0, but also we have is cosh 0 minus 1. That's going to be cosh 0 is 1. 1 minus 1 is 0. So the square root of 0 is 0. So this equals 0, and this is again 4x equals to 0. And then this equals to plus 1, or yeah, just plus cosh x minus 1. This is going to be just positive over 2. And this is again 4x is greater than 0. Yeah, so instead of using this big giant identity like that, what we can do is thus we could use the sine or Signum function, and this is written as SGN of x, and what we could do is write this whole identity as one expression, and this Signum function or Signum function is by definition like this. This is defined exactly how this looks like above, and it's to account for this minus 0 and plus right there. So Signum of x is equal to, like this, equals to negative 1 for x is less than 0, equals to 0 for x is 0, and then equals to, well, positive 1, or just 1 for x is greater than 0. So then we can account for all of these. So we just write this as Signum of x times by square root cosh x minus 1. So thus we have, we could write this entire thing as one expression. So we could write thus sinh x over 2 equals to Signum of x times by square root cosh x minus 1 over 2. Yeah, and here we have taken for account basically whatever x is. If x is less than 0, then that just becomes negative. X is greater than 0 becomes positive, and if x is 0, this is just 0 and doesn't affect anything. So we could write this entire identity as this expression, and when we square this, this just will become x is equal to 1 for non-zero values and equals to 0 for 0 values, like that. And in fact, we could just completely remove it when we square it because this is already accounts for the 0. So yeah, that's a very cool way to simplify the expression like that using the Signum functions. First time I have actually used it. It's yeah, very interesting. Anyways, that's all for today. If you follow along this very interesting derivation video for this half angle trigonometric or hyperbolic trig identity. Anyways, that's all for today. Thanks for watching, and yeah, like always, you can download these exact notes in the link below, as well as viewing these notes on Steemit. Follow me at MES, and also make sure to check out my math forums and post whatever cool math or science related topics you have. Anyways, all for today. Thanks for watching, and stay tuned for another Math Easy solution.